Hey everyone, today we are going to solve the LeetCode question, matrix diagonal sum. So you are given a square matrix, mat, return the sum of the matrix diagonals, only include the sum of all elements on the primary diagonal and all the elements on the second diagonal that are not part of the primary diagonal. So let's see the example. So you are given this matrix, output is 2 because 1 plus 5 plus 9 plus 3 and 7. So total number of these numbers is 25 because so we across 5 twice, but 5 is counted only once. So that's why total number should be 25 in this case. Before I start my explanation, so let me introduce my channel. So I create a lot of videos to prepare for technical interviews. I explain all the details of all questions in the video, and you can get the code from GitHub for free. So please subscribe my channel, hit the like button, or leave a comment. Thank you for your support. Okay, so let me explain with like a 3 by 3 and a 4 by 4. So numbers actually don't matter. We just add a number we find. So that's why I put the dot instead of numbers. So to solve this question, I start from here, 0, 0. Also start from bottom row from here. And then first of all, we calculate this yellow number and this red number. After that, we move next column here. So at the time from top, we have to go down one time because in the end we have to add like this, right? So that's why when we move next, we have to go down one time. So get this number. And then from bottom, when we move to next column, we have to go up one time because we have to go through like this, right? So get this number also. And then next, when we move to next column, so now we move twice. So we have to go down twice, right? 1, 2, and this one. And then from bottom, so we move twice. So that's why we have to go up twice, 1, 2, like this. And then we now get a total. But description said, so we have to, this number, we have to count this number only once. But now we count twice. So that's why when both diagonal meet each other, so in the case we have to subtract this number from total. So I'll show you how to write a code later so that we can get a correct total number. So this is like a odd case, and how about an even case, like a 4 by 4? So we do the same thing, start from 0, 0, and start from last row from here, and then add numbers, and then move next. When we move once, we have to go down once, so that means this one. And from bottom, when we move next, we have to go up once, so this one. And then move next, so now we move twice, so we have to go down twice, 1, 2. And same thing from bottom, so we have to go up twice, 1, 2. And then move next, so we move 3 times, so we have to go down 3 times, 1, 2, 3. And from bottom, go up to 3 times, 1, 2, 3. So for even case, so we successfully like a diagonal numbers, each diagonal numbers only one time. So that's why in this case we don't subtract the like duplicate number from total. So that's why just all we have to do is return total number for even case. Yeah, so that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, calculate the last row equal length of matrix minus 1. And initialize total with 0. So let's loop for I in range and the length of matrix. So first of all, total plus equal. So from top, so matrix and I and I, right? And then from bottom, so total plus equal matrix and so last row minus I, and then I, right? So when we last row is 2, so first of all I should be 0, right? So 2 minus 0 is 2, so we successfully get access to last row, index 2 row. And then when I is 1, so we have to go up. So last row is 2, I is 1, so we can get access to so index 1 row, right? So looks good. And then so if so we have to subtract a duplicate number when we have like a odd like a square, like a 3 by 3. So in the case if I, so from top equal from bottom last row minus I, so if they are same, that means the square is like 3 by 3 or 5 by 5, something like that. So that's why we have to subtract total minus equal matrix and the current I and I, right? And then we finish iteration. So after that, we just return total. Yeah, so let me submit it. Looks good. And the time complexity of this solution should be order of n, where n is like a horizontal length or vertical length. So that's because we iterate through like a matrix with vertical length and just a single loop. So that's why time complexity is order of n. And the space complexity is O1. So we don't use extra data structure, just a last row and total. Yeah, so that's why. That's all I have for you today. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question.